Weighted graphs. As mentioned in a previous video, a weighted graph is a graph where each edge is associated with a number. However, do not think of the weight as a number that describes the edge. Instead, think of the weight as a number that describes the relationship between the two vertices that are connected by that edge. The relationship can be cost, as in the cost of traveling from one vertex to the other. That relationship can be time, as in the time it takes to go from one vertex to another. Relationship can be distance, such as the distance between the two vertices. The relationship can even be something as arbitrary as the number of gas stations between two vertices, which could be a very significant number if you're traveling long distance and you're trying to decide which route would be the safest route to take. Now, that all being said, how do we code a weighted graph? Well, let's start with an adjacency matrix. With an adjacency matrix, there won't be much difference. A 0 would still indicate that there's no edge connecting the two vertices. However, for edges that are connected, and rather than put a 1 at that position in the matrix, we're going to put the weight of the edge connecting them. So for example, for the edge connecting A and B, rather than put a 1 in the matrix, we're going to put 4 in the matrix. For the edge connecting A and D, rather than store a 1, we're going to store 2 in the matrix. For the edge connecting A and E, rather than put 1, we're going to put 5 in the matrix. For the edge connecting B and D, we'll put 6. For the edge connecting B and C, we'll put 3. For the edge connecting B and E, we'll put 8. For the edge connecting E and C, we'll put 7. And for the edge connecting D and C, we'll put 9. And the way this will reflect in our code would be through the add edge method, which is now going to take 3 parameters instead of 2. That third parameter is going to be the weight of the edge connecting U and V. And that's going to be the value that gets stored in the matrix.